Imagine a world where every light in your home, every device you charge, every city that glows at night, all of it powered by the raw, untamed energy of the Earth itself. Not solar panels, not wind turbines, but volcanoes. What if we could harness the immense heat churning beneath our feet and use it to power civilization? What if volcanoes, those terrifying, destructive forces of nature, became humanity's greatest ally in the fight for clean energy? Today, we're diving deep into this explosive idea. We'll explore how it could work, what it would take to make it happen, and whether the dream of volcanic-powered civilization is genius or disaster waiting to happen. Welcome to Imagine This. Let's start with a mind-blowing fact. The Earth's core is as hot as the surface of the sun. We're talking about temperatures reaching over 10,000 degrees Fahrenheit. And that heat isn't going anywhere. It's been there for billions of years, and it'll be there for billions more. Volcanoes are essentially windows into this underground inferno. They're places where the Earth's molten interior breaks through the crust, releasing enormous amounts of thermal energy. And here's the thing, we're already tapping into this power, just on a much smaller scale. It's called geothermal energy, and it's one of the most underrated renewable energy sources on the planet. Countries like Iceland are already geothermal champions. Nearly 90% of Iceland's homes are heated using geothermal energy, and about 25% of their electricity comes from it too. They've built entire power plants near volcanic zones, drilling deep into the earth to access superheated water and steam. But here's where our what if gets interesting. What if we didn't stop at Iceland's level? What if we went all in and decided to power the entire world this way? To understand the potential, let's look at the numbers. The total energy consumption of humanity is roughly 580 million terajoules per year. That's an almost incomprehensible amount of power. But volcanoes and geothermal sources, they could theoretically provide far more than that. Scientists estimate that the Earth's geothermal energy reserves are around 12.6 million exajoules. To put that in perspective, that's enough energy to power human civilization at current consumption rates for literally millions of years. The heat is there. The question is, can we actually use it? In our imagined scenario, we would need to build massive geothermal power plants near every major volcanic and tectonic hotspot on Earth. We're talking about places like the Pacific Ring of Fire, Iceland, East Africa's Rift Valley, Yellowstone, Indonesia, the Philippines, and dozens of other locations where the Earth's crust is thin and the heat is accessible. These wouldn't be your typical power plants. They'd be engineering marvels. Massive facilities with deep drilling operations capable of extracting heat from several miles underground. They'd convert that heat into steam, which would drive turbines to generate electricity. The electricity would then be fed into a global grid, distributing power to every corner of the planet. Sounds incredible, right? But before we get too excited, let's talk about what it would actually take to make this happen. Building a volcano-powered world isn't just ambitious. It's borderline insane. Let's break down the challenges. Challenge 1, location. Geothermal energy is geographically limited. You can't just drill anywhere and expect to find usable heat. You need to be near tectonic plate boundaries, volcanic hotspots, or areas with thin crust. That means most of the world's geothermal resources are concentrated in specific regions. Iceland, New Zealand, parts of the United States, Indonesia, the Philippines, East Africa, and Central America. These are geothermal gold mines. But what about the rest of the world? What about Africa's interior, most of Europe, Australia, or Central Asia? To solve this, we'd need to build an absolutely massive energy transmission infrastructure. We're talking about underwater cables spanning oceans, high-voltage transmission lines crossing continents, and energy storage facilities on a scale never seen before. It would be the most ambitious infrastructure project in human history. Challenge 2. Drilling deeper than ever before. Current geothermal plants drill down about 2 to 3 miles, but to truly unlock the Earth's potential, we'd need to go much deeper, 5, 6, even 10 miles down. At those depths, the temperatures are incredible, but so are the technical difficulties. The rock becomes denser, harder, and more fractured. Drilling equipment faces extreme heat and pressure. Bits break, machinery fails, and costs skyrocket. The deepest we've ever drilled is about 7.5 miles, the Kola super deep borehole in Russia, and that project was abandoned because the temperatures were too extreme for the equipment. But let's say we figure it out. Let's say we develop new drilling technologies, new materials that can withstand the heat, and new techniques for extracting energy from these ultra-deep sources. The payoff would be enormous. Challenge 3: Environmental and geological risks. Here's where things get tricky. Drilling into volcanic regions isn't without risk. You're literally poking holes into some of the most geologically unstable areas on Earth. Could large-scale geothermal extraction trigger earthquakes? Potentially. We've already seen evidence of induced seismicity, small earthquakes caused by human activity like fracking and geothermal drilling. Now, most of these are minor, barely noticeable tremors, but when you're drilling on a massive scale, near active fault lines and magma chambers, the risks multiply. Then there's the question of volcanic activity itself. Could aggressive drilling destabilize a volcano? Could it trigger an eruption? Most scientists say it's unlikely, but unlikely isn't the same as impossible. And when you're dealing with supervolcanoes like Yellowstone or Campi Flegrei, even a tiny miscalculation could be catastrophic. We'd also have to consider the environmental impact. Geothermal plants release small amounts of gases trapped underground, carbon dioxide, hydrogen sulfide, and other compounds. While geothermal is still far cleaner than fossil fuels, scaling it up globally would mean managing these emissions carefully. Challenge 4: Cost. Let's be real, this would be astronomically expensive. Building thousands of geothermal plants, laying transoceanic cables, developing new drilling technology, and creating a global energy network would cost trillions of dollars. It would require unprecedented international cooperation and investment. But here's the counter-argument. What's the cost of not doing it? What's the cost of continuing to burn fossil fuels, wrecking the climate, and leaving future generations with a destabilized planet? When you frame it that way, the investment doesn't seem so crazy. Alright, let's imagine we've overcome all those challenges. The drills are working, the power plants are humming, and the energy is flowing. What does this new world actually look like? First and foremost, we'd say goodbye to coal, oil, and natural gas. A world without fossil fuels. No more oil spills, no more fracking, no more coal mines. Air quality in major cities would improve dramatically. Climate change would slow as carbon emissions plummet. The geopolitical landscape would shift entirely. Countries that built their power on oil reserves would lose their leverage, while nations sitting on geothermal hotspots would become the new energy superpowers. Iceland, already a geothermal leader, would become even more influential. New Zealand, Indonesia, the Philippines, Kenya, and El Salvador would all rise in importance. The United States, with Yellowstone and other volcanic regions, would have a significant advantage. Suddenly, geography matters in a whole new way. Then, there is energy abundance. One of the most exciting possibilities is that energy could become incredibly cheap and abundant. Unlike solar and wind, which are intermittent, geothermal is constant. The Earth's heat doesn't stop at night or when the wind dies down. This means a reliable 24/7 baseload of power with abundant energy. Things we consider expensive or impractical today become feasible. Desalination plants could provide fresh water to drought-stricken regions. Vertical farms could feed growing populations. Electric vehicles would be even more viable, charged by an endless supply of clean energy. Our cities would shift. Why live in areas with harsh climates when you could live near geothermal zones with endless heating and cooling? Iceland could see a population boom. Regions near the Ring of Fire might become bustling energy hubs, with entirely new cities built around geothermal infrastructure. Even space exploration could benefit. With cheap, abundant energy, we could build more ambitious rockets, more powerful telescopes, and eventually energy-intensive projects like space elevators or orbital solar collectors. But this utopia has shadows. The downside is concentrated power and new conflicts. If the world's energy depends on a few volcanic regions, those areas become incredibly valuable and vulnerable. What happens if a major geothermal facility is sabotaged? What if earthquakes or eruptions take plants offline? We'd also see new forms of inequality. Countries without geothermal resources would be dependent on those who do, creating new power imbalances. Energy access could become a weapon, just like oil is today. And let's not forget the people living near these facilities. Would they be displaced? Would they benefit from the energy production? Or would corporations and governments reap the rewards while locals face the risks? So what if volcanoes powered the entire world? Is it possible? Yes, technically. Is it practical? That's where things get complicated. The science is sound, the energy is there, but the engineering, the cost, the risks, and the geopolitical challenges are massive. It would require a level of global cooperation and investment that humanity has never achieved before. But here's the thing, impossible is just a word. 100 years ago, splitting the atom seemed impossible. Flying to the moon seemed impossible. And yet, we did both. If we decided collectively that volcanic energy was our future, we could make it happen. It would take decades, maybe even a century, but it's within reach. The real question isn't can we do it, it's should we do it? And that depends on what kind of future we want to build. Do we want a world powered by clean, abundant energy, where climate change is reversed and humanity thrives? Then volcanic power is a path worth exploring, but we'd have to do it carefully, responsibly, and with an eye toward the risks. We'd have to ensure that the benefits are shared, that communities near volcanic sites are protected, and that we don't destabilize the very planet we're trying to save. The Earth is a furnace, burning with unimaginable heat, and we're standing on the lid. What if we opened it, not to let chaos out, but to let power in? That's the question at the heart of this video, and the answer? It's up to us. Until next time, keep imagining.